So today I'm going to give you guys an overview of my project, Lambda Serverless Search. The purpose here is to allow the benefits of free text searching without actually setting up servers, and to do this at the most minimal cost and still support some level of scaling. There are limitations, for example, the total number of documents you add, how fast things happen, so on and so forth. But nonetheless, it is an interesting project and it is pretty useful, especially if you just want to use a light API before you move to a full-scale search solution. The AWS components I used were S3, Lambda, and API Gateway. And I'll kind of detail that, how did I do all this. But I'll show you how to get started. So you can actually head over to the AWS Serverless application repo and you can search for search. And it's the first one, it's Serverless Search. And all you have to do is click on deploy. And what that does is that it kind of takes you to a screen like this and you have to configure it. There are a couple parameters you need to pass. So the target bucket is kind of like the bucket that needs to be made where these articles will be uploaded to. So just give that an arbitrary name. Just remember that S3 buckets can only be lowercase, so it'll fail. And then the next thing is that there's an internal API key. You guys will kind of learn more as we kind of go on further, like where I'm using that. But for now, just keep it super secret here. Some password that only your admins will know. Then you can give it an S3 read policy and S3 CRUD policy. This is just to allow the Lambda functions to access this target bucket. Once you've kind of built the function, you have all these kind of check marks done. And you want to view that in the CloudFormation stack. And the reason why I say that is because here within the CloudFormation stack and the outputs, the actual URL is being shown. So this is the actual API URL. And in order to actually test this API, within the GitHub README, I've given a link to the Postman collection. So you want to copy that URL, hit run in Postman, and it'll open up a collection like so. And before you get started, you want to replace this base URL with the actual URL. So you can go to Settings, Manage Environments, and add a new environment. And within that new environment, add a key for base URL, and the value is the URL that we just have. I've already set that up for mine with the serverless search prod, so it already has the base URL. So in this particular case, I'm going to create an index called movies, and it's going to have a bunch of fields to index like title, year, director, year, genre, blah, blah, blah. And the reference that I want to get back is the ID. And I did the same thing, except in here, the actual value I want to get back is the title. That's what things should be indexed by. Shards is just the number of records per each index. It doesn't really matter. It's really just a performance thing to kind of play with that number. Our data actually looks like this when we upload it, so just so you guys know. So I'm going to go ahead and create my index config updated. Then I'm going to add this particular document, which has two movies, the Titanic and the Shawshank Redemption. I'm going to run a query against our movies titles index. I'm going to give it a query of Shawshank, or I'm just going to do Shawshaw, just to show you guys that we get our result back. So I've uploaded an article and I'm getting a result back with the Shawshank Redemption. Around 431 milliseconds is the time to get that back. But the idea here and how it kind of works going into the architecture is that when we added a document, we actually triggered this function called a document indexer. And the document indexer, on every object or article that is added, it indexes all of those and it creates this lunar.js, which is a library that's powering the searching index. And that data structure, when we actually call a search query, it goes to S3 and fetches that index and it loads that up in memory of this document search function and it performs that query to give us that result back. So, as we upload and as we kind of pull, we create indexes and we start adding to this articles folder. And this documents batcher, what this function does is that it runs every 5 minutes, and sometimes if you have a lot of articles in that articles folder, it says, okay, well, I'm going to go batch this into one large document, so document indexer doesn't have to keep making hundreds of requests to get all the articles out of S3 and to read the information that they contain. The search config is the indexes that we talked about earlier, and you can read more docs on that here within our README that I've kind of written up, and kind of what does that mean by sharding and so on and so forth. I want to talk a little bit about performance. So again, this is no like Elasticsearch killer or Elasticsearch, um, like replacement, but it is a good way of light API that you could use. And I measured two things. I measured the search query latency, and I also measured the document indexing latency. Document indexing latency really just means I've uploaded a document, how long does it take for me to see that document again? So initially, what I found is that this really depends on the Lambda function's memory. The faster the memory, or excuse me, the higher the memory, the more performance that computer has. So therefore, it's much faster to index it. So at 320 MB, it was a linear kind of going up. But as soon as I upgraded it from 320 megabytes to 1024 megabytes, the latency speed dropped, drastically down around 10,000 records from about 1 minute to only 20 seconds, which is, I wouldn't say it's not too bad. And it's been pretty consistent, honestly, there, a little under 30 seconds. And upgrading it to an even higher memory would probably make that even faster. Search query latency is around 4 seconds at around 1024 megabytes. For 18,000 records. I wouldn't say that's like too bad, but it isn't like, again, like it's not in the milliseconds, which is typical search experiences is what people would say. But the real problem or the real killer here for performance is that I have to go and fetch the index from S3. And that takes a minimum of 2 seconds, which is kind of a non-negotiable. I do kind of talk below about some optimizations I could do to kind of fix that. And so one of the things that you could do is we could upload that index directly into that Lambda function, because these indexes at the core aren't larger than about maybe 2 megabytes, at least for 18,000 records. But even for more, it's probably only like 10 megabytes. But that would definitely fall within the Lambda function's limit, but I don't know if it's dynamically possible to update that Lambda function to actually store the index within the function itself. But that would be a huge performance gain. And yeah, so these are kind of just other things that I've learned. There's a skill test folder in there so that you could reproduce kind of the results that I have done here. So with that being said, this is my Lambda serverless search project. It's also pretty useful for using it on arbitrary sets of data. So for example, in data.gov, if I have some particular JSON data that I wanted to query, all I'd have to do is create an index for these particular fields that I want to be indexed. And I can drop that within this articles folder, and document indexer will automatically read the config, index it, and I could be able to search for it with my search app. Yeah, so that is my serverless search project, and I would love for you guys to give it a shot. Thanks.